Well, well, well. Look who you came back to, huh? You couldn't solve a problem, so you came back to me. Alright, that's enough goofing around. Alright, we're gonna... So, there's multiple techniques, okay? And we're gonna cover every single technique, or try to cover every single technique, to find the equation of a plane. Okay? Because sometimes you're gonna be given 2 vectors. Sometimes you're gonna be given 3 points on the plane. Sometimes you're gonna be given some arbitrary number of something, information. Well, we're gonna actually show you how to find the equation of a plane with 3 points for this video. So, equation, where's my pen? Okay. Plane. So, equation of a plane with 3 points. Bad handwriting. 3 points. Well, let's start it off, okay? Let's pick 3 points. All right? So, P 1 2 3. Yeah, anytime we're doing anything, we're going to have to do 1 2 3, okay? Sorry, I know it's not funny, but 1 2 3. 3 4 6 or some shit. No, don't end that with. What's after P Q A B C D E F G H I J K L M N O P Q, and then point R. Let's say like -1 3 6. Not 6. We ended with 6 already. -2. Ooh, let's put some negative numbers in here. Get it? Get it a little fancy. But what do you do with these 3? Stop stuttering! What do you do with these 3 points? Okay, I mean like. So, what do you need for, let's start off. Once you have these 3 points, let's start off. You need a normal vector to solve the equation of a plane. So you need a normal vector, and you need a point on a plane, and a point on the plane. All right, these are the things that you need. These are the keys to find the equation of a plane. So how do you find the normal vector here? Well, if you have 3 points on this plane, let's find 2 vectors that are stretching from, let's say, Q. 2 vectors that are stretching from Q, right? And those 2 vectors will be along the plane. They will be along the plane. And I'll show you a Desmos representation right now. Okay, now we're back. I've set up the Desmos. I've adjusted the OBS camera angle. I'm letting you know, bro. That shit is so annoying to do every single time. But I do for you guys because I fucking love you. I don't actually love you. Like, I just want to educate you guys. But, well, let's say we're giving 3 points on a plane. This is what we're trying to solve for, okay? We're trying to solve for the equation of this plane. We have no idea what it is, but we get 3 points, and these are the 3 points marked out here. Let's actually solve for the vectors between some point, between 1 point and the rest of the points. So we have these 2 vectors here, right? And then once we have these 2 vectors on this plane, we can actually solve for the cross product of these 2 vectors. And let's turn that on. Remember, cross products give you a vector that is perpendicular to the 2 vectors you put in. So wherever vectors you put inside of the cross product, it has to give you the cross product of the 2 vectors that you put in is perpendicular. Fuck. I said that wrong. But basically, cross product will give you a perpendicular vector. And as you can tell, we have 2 vectors that are flat on the plane. And whatever vector is perpendicular to both of these guys will be the normal vector. So look at here. This vector is awfully normal to this plane. So it's like it just creates a 9-degree angle with the plane. And that's what we're going to do. We're going to use 3 points. We're going to create 2 vectors. We're going to solve for that cross product of these 2 vectors. And now we have the normal vector of the plane. Okay, now that we're back, what can we do? Well, let's find the vector between PQ and PR. Let's go and do that. So PR, the vector between PQ and PR will be named, well, PQ and PR, correct? So PR is 1 to -1. You have to go down 2. 2 to 3 to go up 1, and 3 to -2 to go down 5. So this is the vector from P to R, point P to point R. Let's go from P to Q. So 1 to 3 is 2. 2 to 4 is 2. And 3 to 6 is 3. So now that we have two vectors that are flat on the plane, right? So these two vectors in the video, in the Desmos demonstration, we had two vectors that are flat on the plane. And these are the two vectors that are flat on the plane. Once we have that, we can solve the cross product of these. And then that is our given normal vector. So the cross product of PQ, PR, PQ, PR equal to, man, I hate doing this. It's so tedious. -10. I'm using the method that I use in my cross product, learning how to do cross product video. So if you don't know how to do that, go ahead and watch that. I'm not a sellout. I'm just trying to be educational. Okay, this is 13. Did I do that right? Oh, fuck, no I didn't. This is wrong. This is wrong. This is -4 minus 2. There you go. That looks more right. Yeah, that's better. 13, -4, and -6. There's our normal vector. We found it. We found the normal vector. Right? Once you have the normal vector, just put it down. So the equation of the plane will be 13x, because that's the x component of the normal vector, plus, and let's actually write down, you know what? Maybe I'll write down the formula. Yeah, let's write down the formula. So it's, I don't know if you've seen this before, but this is the formula for a plane. B null and C Z null. And these nulls are any point on the plane. Components of the points on the plane. A, B, C here are the components of the normal vectors corresponding to whatever they're multiplied by. So A is the x component, B is the y component, and C is the z component. Let's plug all these in. 13x plus, and it's not plus, it's -4y minus 6z is equal to, A is 13 times, let's pick which one's easiest to multiply point B. It's literally 1, 2, 3. So 13 times, 13 minus technically 4 times 2 minus 6, which is -6 times 3. And then we get 13x minus 4y equal -6 equal to 13 minus 8. 5 minus 6, 18 is -13. Let's double check that. I literally don't trust my arithmetic after one video. Yeah, -13. Okay, so this is the equation of the plane. Given 3 points. What do? Well, we solve for two vectors, as in the demonstration. So we solve for two vectors that are flat against the plane from one point. And then we got the cross products of them. So this is the cross product of the plane. Answers here. And this cross product is perpendicular to the two vectors that we got, which means it's the normal vector. Once we have normal vector, what we did is plug it into the equation. Ax plus by plus cz is equal to a null, a times x null plus b times y null plus c times z null. And once we have that, there's the equation of our plane. And whatever point you pick, doesn't matter. All the planes will be the same. You can try that on 3D Desmos if you want. Shout out to 3D Desmos for being the best Calculus 3 visualization tool. It's definitely helped me a lot when I'm learning it right now. But let's move on to one more question. Let's pick 3 points. Okay. Let's pick some random points. Okay, let's go with 19 views, because that's my video with the most views currently. And let's go 1901 because I'm lazy and I want easy math. Let's go Q 312 and R, and I'm just gonna use positive numbers because I don't want to make a mistake. I don't know, 1, 2, 4. So let's find the vectors that are flat against the plane from P, Q, and P, R. Now, I'm going to let you know, it does not matter which vectors you pick. As long as the two vectors are starting at the same point, what I mean by starting at the same point, P is first in both these vectors, it doesn't matter. You can literally solve for Q, P, and Q, R, and for the vectors, and then do all the math like that. It'll still be the same answer. It'll be a different answer, but the plane will still be the same. Or maybe you might get the same answer. I don't know. I haven't tried that. But all I know, the math makes sense like that. So from P to Q, arbitrary point we start off to pick first, P to Q. 19 to 3 is negative 16. 0 to 1 is 1. 1 to negative 2 is 1. P and R, so we go 19 to 1 is negative 17. No. It's negative 18. 0 to 2 is 2, and 1 to 4 is 3. Let's find the cross products of this. So PQ crossed with PR is equal to, oh wow, I cannot wait to multiply by negative 17 and negative 18. 3 times 2 minus, wait. 3 minus 2, sorry. Negative 18 plus 16 times 3, which is 48. And what's the last one? Negative 32 plus 18. And once we simplify all this, this is 30, this is negative 14. This is the normal vector for our plane. So all we got to do is plug in the points. X, the coefficient is 1, but it's just x basically, because 1 times x is still x, plus 30y minus 14z is equal to, well, 1 times any point. Let's pick r. That looks the easiest to do all this math with. 1 times 1, because it's the corresponding vector, so this is a x null, a times x null here, plus 30 times 2, so 30 is the y component times the y component of the point. So the y component of the normal vector times the y component of the point. I said that pretty fast. Replay it if you don't get it. Plus negative 14, technically minus 14 times 4. And once you do all that, you get 1 plus 60 minus 1 plus 60 minus 56. 5. Oh, an awfully simple number. So the equation of this plane is x plus 30y minus 14z is equal to 5. There it was. Now, hopefully, you guys can solve for the equation of a plane given 3 points. P, Q, R, doesn't matter what they're named. But if you have any questions, put it down in the comment section. Let's do a quick review. Or, yeah, literally just scroll back to the 3D Desmos example. Man, that shit's good. But let's do a quick review. Find the normal vectors. I'm back on my mouse instead of the pen. Find the normal vectors. I mean, the vectors that are flat on the plane, not the normal vectors. These vectors are flat on the plane. So, in the 3D Desmos example, they're the ones that literally go along the plane. They don't stretch out of the plane. We find the cross product of these two vectors, and then we get the normal vector. And once you have the normal vector, you have everything you need. You have a point on the plane, which we chose R for this example. You can choose any of the points. And we also have a normal vector, which is the cross product. So, hope you guys learned something.